In this lesson, we're going to wrap up chapter 11 by looking at something called the proportional segments between parallel lines. So first of all, let's take a look at this picture. We have a triangle LUV, and we have a parallel line, line MT, running through the triangle. And we want to ask ourselves, why is triangle LUV similar to triangle MTV? First of all, we have those parallel lines, which we want to identify alternate interior or corresponding angles in this case, okay? So this segment is parallel to this segment or line. So angle 1 and angle 2 are congruent because they're corresponding. And then that also means angle 3 and angle 4 are congruent because they are also corresponding. And then by angle, triangle LUV is similar to triangle MTV. So that's what we want to think about. We want to think about the idea that we have this triangle here is similar to this triangle here. And the circumstance is we have a parallel line. So we're going to take a look at some of the implications of that. So now let's look at a triangle with the same idea, except now we know some segment measurements. So we need to find we're going to find the length of segment X here, this little segment BC. So to do that, the only thing we can do right now is to see that this triangle DEC, is similar to this triangle DAB. Again, just like in the warm-up, we have a parallel line that gives us corresponding angles that are congruent, which is then going to give us similar triangles. So that means if we want to find X, this entire segment here, segment DB, is X plus 12. That's the length of segment DB, and that would correspond with segment DC in the smaller triangle. So we can set up the following proportion. So segment DE in the small triangle corresponds to segment DA in the large, and that has to be equal to DC over DB. Substituting in my numbers, 8 over, and again, to find segment DA, I have to add those together. 16 plus 8 is 24. Is 12 over 12 plus X. So to solve this, I go ahead and cross multiply and distribute. Had to grab my calculator there. So we end up with 288 is 8 times 12 plus X. You can either divide both sides by 8, which is what I'm going to do, or distribute the 8 and solve it that way. And so X is 24. So now what I want us to do is I want us to look at, and I'm going to erase this because this got a little cluttered here. So now I want us to look at the ratio of segment DE to AE. So last time, remember, we were doing the segment in the small triangle, which is DE, compared to segment DA, which is in the large triangle. But now we're going to look at these two segments that are cut by this parallel line, okay? So DE is 8, AE is 16, and that simplifies to a half. And then do the same thing on this side. DC is 12, and BC, which is X, which we just found, is 24. And that also simplifies to 1/2. And so what that means is those segments are also proportional. So it's not just the full side length of the triangle, but the actual segments cut by the parallel lines. Okay? So step 2, what do you notice about the ratios of the lengths of the segments that have been cut by the parallel lines? They are proportional. Okay? So that's our conjecture. Oh, we're going to look at the converse first. Is the converse true? That is, if a line divides two sides of a triangle proportionally, is it parallel? Okay, so first we're going to draw an acute angle. So go ahead and use your straight edge to do that. And it says beginning at point P, use your ruler to mark off lengths 8 centimeters and 10 centimeters on one ray. Okay, and then we're going to mark off lengths, it says 12 and 15 here. Sorry, make that 4 and 5. It's really hard to do 12 and 15 centimeters on a piece of paper. Okay, so I'm actually going to do my 8 and 10 on this one and my 4 and 5 on this one. So go ahead, mark here, and go 8 centimeters here and put point A, and then go another 10 centimeters from this point and go ahead and mark point D, or B, I guess. So this will be 10 centimeters. Then on this ray, go 4 centimeters from point P and label point D. And again, use your ruler to do this, and go 5 centimeters from point C and label it D. And then what they want you to do is, oh, everybody's getting all wiggly. They want you to go ahead and connect those segments. So connect A to C and B to D. So what we've done is we've created the setup that we had in the beginning. So look at the ratio of this segment, segment PA, which is 8, to segment AB, which is 10. So we had 8 over 10, and I have it right over here. And then that is equal to 4 over 5, the same ratio that we created on the other ray. So with our protractor, measure angle PAC, so PAC, which is this angle here, and angle PBD, which is this angle here. And if you go ahead and look at that, they should be congruent. Their actual measures depend on the initial angle that you drew, but they should be congruent. And what that means is that segment AC and segment BD are parallel. So this segment is parallel to this segment because if the corresponding angles are congruent, then the lines are parallel. That is the converse of the corresponding angle conjecture. Yes, by converse of corresponding angle conjecture. This means that if a line parallel to one side of a triangle passes through the other two sides, then it divides the other two sides proportionally. Conversely, if a line cuts two sides of a triangle proportionally, then it is parallel to the third side. Let's take a look at some examples of this. So the first question is XY parallel to BC? So we want to know if this segment is parallel to this segment. So we want to apply the conjecture that we just looked at by looking at this segment, AX, compared to this segment, XB. Does that equal AY over YC? Okay, so again, top part over bottom part equals top part over bottom part. Okay, and to double check this, we cross multiply. If the products are equal, 9 equals 9, then the proportion, they're in proportion, which means in this case the lines are parallel. So yes. So in this case, we're trying to find X and Y. So we have a lot of fun things happening in this diagram. It can look a little confusing, but that's okay. So we just have to kind of take it step by step and look at the different types of triangles. So the first thing is I want you to notice that this segment is parallel to this segment. That means that this side is cut proportionally to this side, okay? Because these are the two sides where the parallel lines are hitting. Okay, so the proportion we want to write then is 9 over 15 is 12 over x. Oh, sorry, I have a phone call. I'm going to pause. It was a telemarketer, so that's even more annoying. Okay, back to our problem. So to understand the proportion that we're writing here, we look at the segments that are cut by the parallel lines, and we do this top part over bottom is top over bottom. Cross multiplying gives us 9x equals, I'm going to do 15 times 12, 180, and dividing by 9 on both sides tells us x is 20. I'm going to erase all that and make sure we know x is 20. I'm going to write that in there. Okay, now to find y, we need a second set of parallel lines. So the parallel lines are here and here. So now the two segments that we're looking for are this piece and this piece over this piece and this piece. So that means 12 over y is equal to x, which is 20 over 12. So we did have to solve for x first. If you would go ahead and solve for y first, you would notice that you would have a second variable in your problem, which then you would have to realize then to solve for x first. So that means 20y is 144. And y is 7.2. We could also check this if we wanted. Sorry, I'm going to erase this. By, again, kind of going back to that warm-up idea that we do have similar triangles. So again, in this case, sorry, this was 20, this was 7.2. So this triangle here is similar to the larger triangle here. So if you wanted, you could look at some of the ratios. So this little triangle is 20 over the larger triangle's length would be 32. Is that equal to 12 over the larger triangle? So 12 plus 7.2 is 19.2. You could just double check that. That would be a way to check and make sure you did this correctly. So 32 times 12 is 384. And 20 times 19.2 is also 384. So that would just be a way to check that out. All right, I'm going to continue this lesson in a second video.